All right, welcome everybody. It is my pleasure to introduce our third speaker on the third day of our first BigBlueButtonWorld Summit. This one, I think anybody who's worked with BigBlueButton or used it will find very interesting. I want to introduce Paulo Lorenzen, and Paulo is going to be talking about the media stack that we're using in BigBlueButton and the road ahead. In terms of Paulo's background, Paulo Lanzarin is a software developer from Brazil working at MConf Tecnologia. He has been involved in BigBlueButton since 2017 with a focus on maintaining and improving the WebRTC media stack in BigBlueButton. Over to you, Paulo.
Okay, thanks, Fred. I'll just update my presentation here real quick.
And while Paulo's doing that, just for other people trickling in, it's kind of a fun thing. Feel free to type in where you are coming from in the world and where you are joining from. And if you have questions, feel free to type them in the chat, and then we'll try to sort of gather them up near the end of the presentation.
Okay. Hello, everyone. Fred already introduced me, but I'm Paulo Lanzarin. I'll just skip over the introductions, but I've been working with BigBlueButton for a while now and mainly focused on our WebRTC stack right now. So the agenda for this presentation will be first an overview of our current media stack, so how it works, which are the components involved, and then an outline of the challenges we are aware of and we are facing right now. And then what are some of the next steps we are planning to do in the coming releases to actually try and tackle those challenges. And then some wrapping up and questions and answers. So first of all, our current architecture, I'll talk about a bit about our RTP topology, because BigBlueButton's RTP topology is something not usual to other open source video conferencing systems. We are using a mixed RTP topology because we have two different media servers in action here, which is Granto, the first one for webcams, screen sharing, and listen only. And it's been used as an SFU, which is basically a packet router. And that means basically that, for example, in a conference of 5 people with 5 webcams, the server is actually managing 25 webcam streams. And then the second topology we are using is with FreeSwitch, which we use. FreeSwitch is much more than a media server, but we are using a tiny fraction of it, which is the mod conference plugin, which actually implements a video conferencing plugin inside FreeSwitch. And that uses a MCU topology. We use that for microphone, and that basically means that every microphone streams BigBlueButton handles is mixed together and take back to the client. And that means that a conference of 5 people with 5 microphones, it's basically 5 streams which FreeSwitch is handling and mixing. So 2 different things, various reasons as to why we do that. The second area of our current architecture I like to talk about real quick is how our media signaling is structured. And by media signaling, I mean how we transport the SDPs back and forth the client and server, and the ask candidates, and etc. We have in BigBlueButton 2 separate media signaling pathways, and that's basically because of the fact that we have 2 different media servers. The first pathway is with FreeSwitch, which is actually a C protocol running over WebSockets, and the HTML5 client talks directly with FreeSwitch via Nginx and negotiates the microphone streams through SIP, because that's what FreeSwitch speaks mostly through Sophia SIP. And then the second pathway we have for signaling is through BigBlueButton's SFU, which is a custom JSON protocol over WebSockets. So the HTML5 client open a dedicated WebSocket with BigBlueButton's SFU, also through Nginx. And then that's used for signaling webcams, screen sharing, and listen only. And then BigBlueButton's SFU, which is a subcomponent of BigBlueButton, actually plays the role of actually acting as an abstraction layer over both Granto and FreeSwitch. And then our current architecture, talking about specifically how the HTML5 client code for WebRTC is structured. Right now, each media type has a decoupled implementation from one another, and by media type, I'm talking about webcams, screen sharing, listen only, and audio. Of course, that has pros and cons. The pros being that errors in a component doesn't necessarily escalate to audio and vice versa. And the cons mainly is that the maintenance overhead is bigger. And for the browser WebRTC APIs, we are using two different wrappers. The first one is zip.js for microphone, which is basically it plays two roles. One is implementing a zip stack to talk with FreeSwitch, and also acting as a WebRTC API wrapper. So we don't need to necessarily deal directly with the WebRTC APIs, and that's used for microphone. And then second wrapper is Granto Utils.js, which is utilitary from the Granto folks, which abstracts the WebRTC API as well, and that's in use for audio, for listen only, webcams and screen sharing. And then this is a small diagram of how those three pieces, the media servers, the client, and the ceiling, fit together with the BigBlueButton architecture. And as you can see, it's quite a bit complex due to having two media servers, two signaling pathways. So we have a protocol here which the client uses for webcams, and then we have zip for microphone, and then we have two different RTP flows for FreeSwitch and Granto. And we have some components which I did not mention, but actually also play an active role with media state handling, which is the AKFS ESL component, which through the FreeSwitch event socket layer is the one which orchestrates the audio state with AKApps and consequently the HTML5 client. And then AKApps, which is the central business logic unit of BigBlueButton. So that basically covers the general overview of our current media architecture. What I'd like to talk about now is which are some of the challenges we face with that architecture. That's mainly 5 areas of challenges and pain points. I'll start with the first one, which is basically the user experience. Of course, all those classes are about user experience, but these are the ones that actually blow up in the face of the clients. And the first one, which is a classic one, it exists for 10 years or more, which is the microphone versus listen-only separation. It's something that's not common in other video conferencing systems. End users which are not used to BigBlueButton complain about that. It's a point of confusion. People don't understand why there's that separation, and the process of switching between one and another is painful. But basically, we have that separation due to a technical limitation, which is FreeSwitch being an MCU. So we can't actually put 100 microphone users in an 8-core default server in FreeSwitch without taking resources from every other component like Meteor or Granto. So listen only is a middle term where we are using an SFU to use less CPU and allow more people to listen to the conference. That's the first pain point. And then the second pain point is we have some overzealous constraining measures for webcams right now, mainly pagination. It's a necessary constraining measure, but it's a pain point because users want to see 25 webcams concurrently in a conference or 30, and sometimes pagination doesn't allow that. And that's those constraints are there for a reason, which is basically preventing Granto from stop operating properly. So we need the constraining measures, but we'd like to be able to use a media server which actually supports bigger scenarios, which are important for education use cases, etc. And then negotiation times, which is also a big complaint for the user experience, is how many seconds do you take to join microphone in a conference or webcams? The media which goes through Granto is usually fast enough in ideal scenarios when Granto is not overloaded. The FreeSwitch is a bit more complicated due to various things, one of them being the lack of frequency, the others being some network scenarios which doesn't actually work properly with FreeSwitch in regards to ICE connectivity checks. So that usually generates I'm taking 15 seconds to join echo test. That's a problem. Then there's the video quality, which is also based on the worst user connection in the video conference. That's a problem because we don't have simulcast. So that's not a bug, that's by design, but it's a limitation of Granto. And that's a major complaint as well. A weak reconnection handling. We can't do ICE restarts with the media servers we have. So we have slower and clunkier reconnection procedures for media, which sometimes are more error prone. It's a problem. And we can't smoothly prioritize audio over video due to our client-side peer connection structure. So it's not straightforward to do that. And then there are challenges when talking specifically about Granto. So the first one is stability, which used to be a bigger deal. It isn't that big of a deal now. It has improved a lot. And I'm mainly talking about stability issues which actually make Granto stop working, which is WebSocket stack locks, crashes, which we fixed 10 of those over the past 2 years, and it rarely crashes today. And then there's the memory fragmentation and leak problems. If observe Granto memory usage, it uses a lot of memory, and it usually doesn't releases it as it should, so it's a problem. And then scalability. Granto doesn't scale vertically as well as it should, so that's a big problem. It doesn't work if you have a 64-core server. Granto won't use all those cores because there are other limiting factors in Granto which prevent that from happening. The negotiation efficiency, Granto has a very unique characteristic of using a lot of CPU, doing a lot of context switches during the negotiation phase. So that brings us to the infamous scenarios of 30 people trying to enable their webcams at once, and that doesn't always work. Big pain point, this one. And then the media processing efficiency. Usually, if you manage to share 30 webcams, the stable CPU usage is fine, but it should be a lot lower because Granto should be only a packet router. It shouldn't be transcoding or nothing, but it uses 2% of a core per media stream, for example, and should be a lot lower. And then the feature set of Granto, which is lagging behind a lot. We don't have VP9. We can do bundling of media streams of the same type. We don't have transport-wide congestion control, don't have simulcast. We are RMB only, and the list goes on. So big problem. Challenges to FreeSwitch. We face some of those with FreeSwitch as well. Vertical scalability for FreeSwitch is okay. It actually scales vertically pretty well. But it is still an AMCU, so very CPU intensive. That's why we have listen only and why what I explained before. Negotiation times, which I mentioned in the user experience session problem. People complain a lot that the echo test or the audio connection actually takes a long time in some scenarios to be established. The profile stickiness, what I mean with this is that FreeSwitch dual stack support for IPv4 and IPv6 is weird. It doesn't do full dual stack. It actually has a strategy where if the signaling transport, the WebSocket is through IPv4, it will only accept media, UDP media through IPv4, and then WebSocket transport under IPv6, only IPv6. So that's very problematic on some specific network scenarios. And there's no indication from upstream that this will be fixed, so a problem. Audio quality community has done a lot of work in trying to improve FreeSwitch audio quality. we've seen those improvements, but there are still issues with mixing artifacts, jitter buffer walls, and stuff. So still a complaint, even if there were improvements over the last year. And the feature set, the same as Granto, it's lagging behind. No proper bundling support, no transport-wide congestion control, no RTX retransmission, etc. And then another challenge we face, which goes into the HTML5 client area, it's our current peer connection structure. So if you look at the Chrome debugger, we currently open a peer connection in the browser for a media stream. So the ratio is 1:1, one peer connection per media stream. So for example, if you have 25 webcams in a meeting, we'll have 25 peer connections, and microphone 26 and screen sharing 27. That implies some stuff, which is the ICE lifecycle, which is gathering connectivity checks, bound sockets, etc., will be done 27 times in that example. This is very bad because it's inefficient network-wise, wasted bandwidth with connectivity checks. Number of bound sockets, both in the client and the server, is very bigger than it should be. Memory usage and CPU usage is higher. So that's both a client and server side issue. The ideal scenario is where we use a single peer connection for n media streams. So BigBlueButton opens just a single peer connection, and that's it. A single transport, a single ICE negotiation that speeds up the negotiation for media, that makes it more efficient. But we can do that because Granto and FreeSwitch don't allow us to do that. So it's a problem we have to live with right now. And one of the final challenges is maintainability. I'm showing the diagram I showed before to demonstrate how having two different client-facing media servers makes things harder. So we have to maintain basically two different media servers which do the same thing, which is media, WebRTC media. So that's problematic. For instance, we had to debug problems in FreeSwitch and Granto simultaneously, and we are short on hands, and that just complicates matters further. And then the undocumented client and server components like BB, WebRTC, SFU, FreeSwitch, and Granto, which makes the entry level to the code higher for the media code specifically, and which kind of, I think, freaks out some of the community to actually try and contribute to the server side and inner workings of the BB WebRTC stack. So challenges being laid on the table, we have two things about ways to actually tackle them. So I'm going to be talking about a bit the next steps we are trying to take in the coming releases to actually circumvent some of those challenges. The first one is finding an alternative to Granto, which is, I think, the biggest pain point right now for BigBlueButton. The Meteor side has improved a lot over the past year. FreeSwitch is stable apart from its issues. Granto has also improved a lot over the years, but it's not sufficient. It's a bottleneck still. And we are in a place where the current media stack works for the majority of use cases, but on some scenarios, like 35 webcams being enabled at the same time, it fails spectacularly. It's just bizarre. So what we actually did last year was we put a set of mitigations and constraining measures which were originally scheduled for 2.3, but due to the pandemic were backported into 2.2, which is video pagination, dynamic camera profiles to reduce CPU usage all across the board, hard media limits, the use of multiple Granto instances to increase reliability. And that put us in a place where stuff works and people are able to use it. And we have some time to actually think about doing more aggressive changes to our media stack. So the media stack should be a lot better, and we have two options to do that. Keep trying to improve Granto and we've done a lot of that since it was first introduced back in 2018. For those who didn't see that, back then we couldn't even share 8 webcams concurrently, and now we can share 30, depending on the scenario, and it just works. Crashes are much more sporadic. The negotiation times improved a lot, and that was a lot of back and forth with the Granto team and trying to improve a open source project, which is neat. But the option we are taking right now is, we think we've done what we could to squeeze what performance out of Granto. So we are actually trying to look for something else in the open source ecosystem. So for us, by swapping Granto, I'm adhering to a set of basic principles, which is maintaining feature parity. We don't want to lose anything, listen only, screen sharing, webcams recording, pagination, etc., because that's just not a thing. The gradual rollout, we don't wish to change everything at once, like it was at the beginning of the HTML5 client media stack implementation, which we had to do everything from scratch because it was a transition from Flash, Red 5 to Granto. But now we have something that is working and we have time to put it together in pieces and carefully. So gradual rollout, avoiding burning bridges, which is basically we will keep Granto working for the time being, and so people can actually use BigBlueButton. And then look carefully, which is test every media server and try to break it tirelessly so we can make the right choice. The stage we are at for Granto is prototyping. So we are prototyping with alternatives. That prototyping is being done in BigBlueButton itself, so it's not a demo app, a standalone app. We are doing it inside BigBlueButton, so it's usable in a regular conference, and that's been done through media server adapters bolted in BBB WebRTC SFU, which I mentioned before. Is supposed to be a media agnostic media controller, so we can put drop-in adapters in there and say, okay, so we configure in settings.yaml in BigBlueButton HTML5 the option to tell BB WebRTC SFU choose Janus, for instance, and it will do that. So it can coexist with Granto and FreeSwitch. The timeline for that is hopefully we will have experimental adapters for Janus, MediaSoup, and Meduse in Q4. That depends on the feature freeze timeline. If it is stable and then I'm back from vacation, it will ship, but we'll see. It's something we still have to work through. The process has been actually to get a list of available candidates in the open source ecosystem, of course, and we've come up with a few, which are those 6 candidates. I've experimented with all of them, but I will be focusing on those first 2, which are the ones where we are most advanced at and we had more success yet. So first candidate we are exploring is Janus. A lot of you may know Janus. Janus is a very interesting project where it's a media server with a link core, but a treasure trove of plugins which are very interesting and do different stuff. And so the approach we are using is actually implementing an adapter in BB WebRTC SFU, which uses Janus Video Room plugin, which is a ready-to-go conferencing system for WebRTC conferencing system, basically. It has its advantages, which is faster to get it going, and it should be faster to try and come up with something to scale it horizontally, for instance, with an API proxy, and it's a well-maintained project. So that's just positive points about this. There are some cons, which is Video Room is an opinionated plugin, so we have to follow its protocols. It's not that extensible unless you chain other Janus plugins on top of it. And I had to alter some client-side stuff because the Video Room plugin admits that the negotiation flow for SDP will be done on some specific ways, which we were not prepared yet, but nothing that couldn't be overcome. And the second one is MediaSoup. MediaSoup is kind of different from Janus, as in it has a link core, but that's just what it has. It doesn't have a plugin infrastructure around it. It has a small core API, which you can kind of work to build a conferencing system. It's very simple, very performant, but it has no built-in recording, which is a problem for us because we need recording, but nothing that couldn't be overcome. So for instance, I experimented with recording the streams from MediaSoup with Granto, which is a testing option. And then that works, but we can also experiment in recording streams with FFmpeg or GStreamer. It shouldn't be that much of an impediment for MediaSoup. And then another point of the prototyping and development process is, since we are doing that kind of stuff inside BigBlueButton SFU, it's something we have to look at its performance as well, because it's also a concern. We don't want to find a media server which is 10 times more performant than Granto, to only discover that now BigBlueButton SFU is a bottleneck to signaling overhead. So what we are doing concurrently is actually profiling and testing it to see if it is, what are its limitations. So we added instrumentation with Prometheus to it, to be able to profile API times, etc., and as well as a mock media server adapter, so we can stress test signaling without needing to have a full-fledged media server. So that step of testing and profiling are work in progress. When we find the bottlenecks, we'll try to improve that and fix that. So when we arrive at a scenario where we have a stable media server adapter, our signaling component also is able to handle the load. And then there are the tests. So we are executing load tests as the prototypes are being developed, which is a bit different from what happened with Granto when it was first introduced, which we only started doing load tests a while into the process. So an example test scenario we are running while developing is 1,450 webcam streams at 200 kilobits, which for an 8-core server right now is already problematic for BigBlueButton. And with dynamic camera profiles disabled to actually stress it a bit more. And the media servers and MCS core, which is a subcomponent of BigBlueButton SFU, which implements the media server adapters, are running apart from BBB in a separate server, so we can measure just their performance characteristics. So for this example, what I'm showing, the server specs is a 2nd generation EPIC processor with 8 cores and 16 gigabits of RAM. The first scenario I'd like to show you from a test is the idle CPU usage, which is the main metric a lot of you may look first for media servers in a server environment, right? So the higher the curve is here, the better, because the more CPU is free, which means the media server is using less. And this is the result for the test I mentioned before. Granto, the green line is Granto, so it's what we have in 2.3 right now. And it's the most inefficient one by far. So this is the lowest idle CPU available for the testing session, the lowest 5% actually. So Granto is 31% and Janus is 21% more efficient than Granto in this scenario specifically. And then MediaSoup is 20% more efficient than Janus, for instance, with 8 workers. A characteristic I forgot to mention about MediaSoup is that vertical scaling in MediaSoup is actually controlled programmatically. You as a programmer, so us from BigBlueButton, we control how many workers, media server workers, we will spin in MediaSoup to actually handle media. So 8 workers for 8 cores from the machine. I also put 1 worker which is actually constraining MediaSoup to use just 1 core from the machine as a testing measure. you can see it just uses one core, but the experience was a bit degraded for the client. So there were delays and packet loss and some extreme artifacts, and 8-core, 8-worker procedure was actually good. So this demonstrates how much of the server-side scalability and stability we can improve by changing Granto. This, of course, is one of the metrics. The other one is use memory. So I mentioned that Granto has problems with memory fragmentation and leaks. So we are actually taking a look at memory usage. Janus is the yellow line. It's by far the most memory efficient of all. Lower is better here. So Janus is the most efficient, and then MediaSoup and Granto have similar memory usage, but I'm not confident that the MediaSoup CPU usage is not a mistake on my part yet. Again, this is still in development. The difference between Granto and MediaSoup is that MediaSoup actually releases the memory instead of Granto, which releases just a small fraction of it. So it uses roughly the same, but it doesn't leak as much, which is good. So another metric I'd like to show is context switches. And why I'm showing context switches is a problem with Granto, which is negotiation times I mentioned before. I've talked in the GitHub issue tracker and mailing lists twice or three times now, which one of the biggest problems with Granto is actually the number of threads it spawns and the context switching overheads that incurs. So if some of the administrators here once took a look at how many threads a Granto instance was using in a server with 1,000 streams, it was using 8,000 threads. So that context switching overhead might be a problem with negotiation times, and the reason why it's like that is because it's a structural problem. It uses GStreamer, and GStreamer has concurrency done automatically, and that's just how it works. So this is a comparison of how many context switches each media server does, and then Granto is just absolutely higher than the other Janus and MediaSoup. In fact, the exception of Janus having a weird uptick in context switches at the end of the session when all the media handles were released, but that's something that needs more investigation. But overall, every other candidate is better than Granto in that regard. And then interrupts, system interrupts. It's a similar metric to measure the negotiation time and the context switching problems. Granto also has. Every one of those peaks are negotiation peaks. So it's a batch of media streams being negotiated. So we can see the problem here. So that finishes the ongoing work about replacing Granto, but that's not the only thing we need to do in BigBlueButton in regards to media to actually improve it a lot. So the client, the HTML5 client media code also needs some attention. So there's something we need to be done in the foreseeable future. The first one is actually making the HTML5 client media bridges configurable and extensible, tentatively into 4 if there's time to do it. What that means is that you can actually choose if you are using Granto and FreeSwitch or Janus or MediaSoup via the HTML5 client, and every implementation is decoupled from one another. That's something that needs to be done. And then we have to reduce the number of concurrent media signaling WebSockets. So right now we have 2 signaling pathways, but the WebDB, WebRTC, SFU components, each one of them open as a single WebSocket. So we can have up to 5 media WebSockets open, which is very inefficient. These need to be improved. We need to replace Granto utils as a WebRTC wrapper in the client because it's deprecated, it's lagging behind. And then we have to address the client's peer connection structure problem, which I mentioned before. That depends on the media server we are choosing, but ideally we want to have 1 peer connection per session at the maximum of 2 peer connections, which is 1 for the sending streams and 1 for the receiving streams. So we can actually negotiate ICE 1 or twice and not 25 times. this is just a diagram of how a midterm client restriction would look like. I just skip over this due to the time. Another thing we need to improve is the client's media feature set, which is where we are. We always are here. And then the work which is being done in 2.4 is we've fixed the screen sharing mirror effect, which is a UX problem which has a long-standing UX problem. We need to prioritize the floor's camera quality when dynamic camera profiles are enabled. So when the active speaker is talking, his webcam actually has normal FPS and normal resolution and not 2 FPS. That would be a neat addition. And then there's the webcam background blur, which is a big requisition from every end user, and you should stay tuned for the next presentation from the Lionsgate folks, because they are the ones who looked into it. And then simulcast depends on the media server, but we need to do that because basing the video quality on the worst connection in a conference is just not ideal. So we need to fix this. And then there are the under the hood features that will come when a new media server is chosen, which is a better congestion control algorithm, VP Night, and in the future, hopefully AV1, SVC, RTX, RED, and when it's implemented. And these are just some. There is a lot of more stuff that will be done, that needs to be done, and they are or will be documented in the GitHub issue tracker. Another thing that we need to improve, and that's a more of a long-term plan, is actually trying to have a single media client-facing media server. So we have FreeSwitch and Granto talking with the end users right now, but we need just one, because that would imply in a simpler maintenance overhead, a simpler architecture, better quality, possibly better negotiation times. And then you can compare this diagram to the one which I showed before, which showed the entire architecture. It's much more simpler, and it's something we should strive for, and something that we are planning to do when there's time. And then the final point, and that's something that we've been always thinking about, but we've been thinking about that increasingly frequently in the last few months, which is working toward horizontal scaling. Right now, the media servers run inside this BigBlueButton server, but ideally we would like that media servers were scaled vertically, horizontally, in separated servers. So we would have a cloud of Janus media servers, for instance, and a cloud of FreeSwitch, and there are various ways of how we can approach that. And it's something we need to think about. We are thinking about. We didn't start any work on that right now, but it's something that we should discuss internally and with the community in the future. And then that's basically it for my presentation. I'm just wrapping up for how you can keep up with the progress and what activities are documented or not. Activities will be documented in the GitHub issue tracker. There's a project called Media Stack where every issue related to the challenges I mentioned here are or will be registered. Not everything is registered, but I plan on completing that list soon. A document describing this initiative and this presentation is on the link on the presentation, which is a page, a link to a Notion page. It's a living document. It's always being tweaked upon. It's not finished, and it's being completed as we find newer stuff and make strides in developing the prototypes. And of course, calls for testing when prototypes are up, and updates might be issued on the BigBlueButton dev list. Discussions are always welcome. The expertise of the community is welcome. Testing help is welcome. And that's pretty much it. If you have questions. Yeah, just one question I want to jump ahead and answer real fast is one feature set, which we'll still need FreeSwitch for dial-in. Yes, we still need FreeSwitch for dial-in, and that's why FreeSwitch is here. So FreeSwitch does not face the client. Another media server face the client, and then there's this orchestration, and then a dial-in user can just talk FreeSwitch and then we orchestrate internally, because by orchestrating internally in the infrastructure, we can rule out network problems, we can rule out different browser versions, and etc. So this is things that FreeSwitch is not going away. It's not going away, but ideally, I wish it would go away from the client-facing side. But yeah, that's it. Thank you.